So your first question is that the fundamentals premise of biochemistry about how life works is that it is the
Oh, it's physics and chemistry that explain life processes.
no, it is about biology and chemistry, which explain the term biochemistry. And other life sciences help to explain as well the term biochemistry. By using chemical knowledge and techniques, biochemists can understand and solve biological problems. By using the knowledge of biology and chemistry and other life sciences like physics and physiology. So mainly biochemistry is a marriage between biology and chemistry, and other life sciences comes after that. Okay.
Mhm.
Second, this was first strongly established by 1897 experiment result showing. This experiment performed by Edward Buckner discovered that yeast extract with no living yeast fungi can form alcohol from a sugar solution. So how he has made that alcohol from sugar by using the extract from that yeast fungi, and that extract contains zymase enzyme which convert sugar into an alcohol. So it is a cell-free environment that he has provided to convert sugar into an alcohol. So you can say zyme is produced by yeast cell and used in cell-free fermentation in 1897. Okay.
Mhm.
Give one property of water that indicate it has unusual strong intramolecular interaction. That is high surface tension. Why water has high surface tension? Because of its one property. It is hydrogen bonding, strong hydrogen bonding, which has strong binding with itself. So that's why it has high melting point, high boiling point, and high heat of vaporization, which make it a universal solvent. It also known as a universal solvent because of its three characteristics. One, hydrogen bonding. Second, it is polar. And third, it has high heat of vaporization. It cannot produce vapors until the temperature reaches to 100 degrees centigrade. So it has a very high heat of vaporization and a very innate ability of hydrogen burning like this. Here you can see what is hydrogen burning, highly electropositive, have burning with the highly electronegative atoms like FON. Here you can see the O atoms have partial negative charge and hydrogen atom has partial positive charge, and it has strong hydrogen bonding with the other partial negative water molecule which contain oxygen.
Mhm.
Then what is the authentic reason for the hydrophobic effect? What is hydro? Hydro mean water, phobic mean heating. Anything which has property of water heating is known as hydrophobic agent. Like our oils are insoluble in water. Why? Oils are non-polar and water is polar. So oils are insoluble in water and they have hydrophobic effect. What is the rule of nature? Like dissolve like. polar dissolve in polar, and organic molecule dissolve in organic solvent. So you can say the hydrophobic effect is that fact in which non-polar molecule cannot dissolve in water. So you can say hydrophobic effect is genuinely the interaction of hydrophobic moieties or molecule when they are surrounded by hydrophilic environment like water. So if you add oil or fat in water, it has specific gravity less than 1, which is a density of water which is around 1. So oil molecule float over the surface of water. Why? Because of its low density and non-polar nature. Then sketch the expected titration curve for fully titration of carbonic acid. Carbonic acid is a weak acid which have 2 pK value because of its nature. It has 2 replaceable hydrogen ion, H2CO3. When one hydrogen ion is removed and there is a equal amount of salt and acid, then we have a pK1 value. So the pK1 value obtained at pH of 6.4, where the carbonic acid and bicarbonate, sodium bicarbonate salt concentration becomes equal. So when we add more acid, then when we add more base like sodium hydroxide on the x-axis, we increase the concentration of sodium hydroxide on the x-axis. What happens? The second proton which is present in the bicarbonate ion, it also removed at the pH of 10.3. So we increase the pH of that solution. What happened? The proton get removed, and when we have equal concentration of acid and its salt, that represent the pK1 value. And the second, when the second hydrogen or proton is removed from the bicarbonate ion, we have sodium carbonate and salt. So that is the titration curve where we represent pH at the y-axis and quantity of base at x-axis. So as we add the quantity of base, the acid get neutralized and we have salt along with the acid. So pK1 value for the carbonic acid is 6.4 and pK2 value for the carbonic acid is 10.3. Here you can see Ka value represent the dissociation constant of an acid. High the value of Ka, then the high value of its dissociation. So in this graph, we have 2 pK value because of 2 replaceable hydrogen ion present in the carbonic acid. Then consider a buffer which at hydrogen ion concentration 10 to the power minus 6 moles has 100-fold more of the base form than its conjugate acid solution. Then what is the pH of that acid and buffer pK value? pH is around what is the formula of pH is negative log of hydrogen ion concentration. And what is the hydrogen ion concentration? It is 10 to the power minus 6. So we put the value in the equation. pH is equal to negative log of hydrogen ion concentration. Then 10 to the power minus 6, this minus 6 will multiply this with this minus sign. So 6 log of 10 log of 10 value is equal to 1. So we have pH around 6. What is pK? pK is negative log of Ka. And we have a, base value 100 times greater than acid value. Then we can say it's a 10th power minus 4, because 10th power 2 mean 100. So negative log of 10th power minus 4 is equal to 4. So pK value is 4. pH is around 6 and pK value of 4.
I was thinking that it'd be, if it's 100-fold, would it be 10 to the 2 because it'd be doubling, or would it, so it'd be 10 to the -4 because it's like, could you explain how you got 4?
This is base concentration, which is 100 times fold than that of acid. So what is pKa value? pK value is that value from in which acid and salt concentration is equal. Acid and salt concentration is equal. So he says the salt and acid concentration becomes equal when we have base concentration 100 folds than that of acid. Okay, so that's why we put 10th power minus 4, not 10th power minus 6. Okay, at 100-fold concentration of base, we have pH is equal to pK, which is around 4. At that pH 4, we have equal concentration of acid and salt. So pK value is that value in which salt and acid concentration becomes equal. So at pH 4, the salt and acid concentration becomes equal. That's why pK value is 4. Okay, you got my point?
Yeah.
In isolactic focusing, why do proteins stop moving when they reach their pi value? Why? Because they do not have charge at the isolactic point. So lactic mobility depends on charge and density and mass. So here you can see the lactophoretic mobility depends on two things. One is charge and other is density and size. So if we have a large charge on the protein molecule, then it moves faster. And if we have there is no charge on the protein molecule, what happens? There is blockage of the movement of protein, stoppage of the movement of protein. And if we have protein has a high size, then it has less movement, because lactophoretic mobility is inversely proportional to its size and viscosity. You got my point? Then we have a question. Consider a protein with a charge of 10, that is 2 nanometer away from another protein with a charge of -4 in water. Set up an equation to calculate the interaction energy in kilojoule per mole. This is the formula. It is very easy. We have value of K, which is around 140. Then Q1, which is given, it is 10. Then Q2, which is around 4 minus 4. Then divided by epsilon R. R is the distance between two protein. And epsilon value for water is fixed, which is around 180. So the value of delta G, mean Gibbs energy, is around minus 35 kilojoule per mole. So you can put the values in this formula and you can obtain the desired value. Then we have a salt solution are known to mask electrostatic interaction. How would 0.2 molar NaCl versus 0.2 molar magnesium sulfate compare in their ability to mask this interaction? Explain briefly. Here you can say the electrostatic interaction masking is directly proportional to the ionic strength. So the ionic strength of magnesium sulfate is more than NaCl. So electrostatic interaction is more in magnesium sulfate due to its high atomic size value. So magnesium has higher atomic size value. That's why it has high electrostatic interaction masking ability. So you can say it has high ionic strength. That's why it has high electrostatic interaction masking ability, weakening ability. Is it clear to you? This is due to the high atomic size of magnesium sulfate molecule. This is due to the high atomic size of magnesium sulfate. Then we have energy. We have two laws of energy, first and second. First law explains energy cannot be created or destroyed, but only converted to other forms. This means that the amount of energy in universe is constant. Second law explains all energy transformations are inefficient because every reaction results in an increase in entropy and loss of usable energy, which is known as free energy as a heat. As you can see, we eat food to get energy. Only 25% of our food is converted into ATP. 75% energy which is obtained from food is dissipated as a heat to maintain our body temperature around 37 degrees centigrade. So this is the loss of energy. Here you can see with the help of an equation. H is known as enthalpy, the total heat of a system. The total heat content of a system is known as enthalpy. This is the definition of enthalpy. Then Gibbs free energy, the amount of unusable energy in a system that can be used to perform a work. That is known as Gibbs free energy. The amount of usable energy in a system that can be used to perform a work. It is known as free energy. Then what is entropy? The amount of disorder in a system which is dissipated. In most but not all the cases, it is heat. Then we have Gibbs free energy. It is changed in two levels. Then we have enthalpy. It is changed in two levels. Then we have disorder. It is change in two level. And this is mostly the dissipated heat. This is the equation which explains Gibbs free energy. Delta G is equal to delta H minus T delta S. So this delta H explains the total heat content of a system and minus disorder in a system. So the relationship between the value of delta G and the spontaneity of a reaction. This is very important. In endergonic reaction, we have delta G value positive. In endergonic reaction, we have delta G value, Gibbs free energy value between two substrate and product, we have positive value. And in the exergonic reaction, we have a delta G value negative. And in a reversible reaction, we have delta G value almost zero. So during endergonic reaction, we have backward reaction in most of the cases, and in exergonic reaction we have a forward reaction most of the time. So here are three G's which represent the Gibbs free energy: delta G, delta G naught, and delta G naught, comma. Which one is more important? Delta G is the free energy differences of a system in any condition, in any temperature, at any pH. So if we do not have any sign over delta G, it means it is free energy difference in a system. We do not apply any condition of pH, temperature, or any pressure. So delta G naught free energy difference of a system in a standard condition, which is around 25 degrees centigrade temperature and 1 atmosphere pressure. And what is delta G naught, comma, free energy differences of a system in standard condition at pH 7. So here we add an extra parameter of pH. Never forget that delta G determines the feasibility of reaction, not delta G or delta G O, comma. So delta G mostly was used in the chemical reactions. Under some condition, ATP can drive the synthesis of high energy compound creatine. Even though creatine has high standard free energy of hydroxyl, this reaction is so we have creatine plus ATP by creatine phosphokinase. Then we have creatine phosphate plus ADP plus proton, and delta G for that reaction is plus 43 kilojoule per mole. Then we have ATP hydrolysis energy, which is around minus 31 kilojoule per mole. So the difference in between two energy is 12 between first reaction and second reaction. So we can see, we can say during this reaction the energy difference is around 12 kilojoule per mole. Here we have a equation that represent the free energy of ATP hydrolysis under physiological condition. So if you can find out the free energy for water, you can apply that formula. Delta G is equal to delta G plus RT ln Q. Write an equation giving delta G for the reaction at specific intracellular concentration at pH 7. Like this previous equation, we can write it delta G is equal to delta G naught, comma, plus RT ln and that molar ratio of product to that of reactant. Molar ratio of product to that of reactant. Assume that a certain cell at 37 degrees centigrade, the delta G for the above reaction is plus 6 kilojoule per mole. Which direction will the reaction proceed spontaneously? I have told you what is that reaction. During
It
endergonic
would be
reaction. During endergonic reaction. This is endergonic reaction. This is endergonic reaction. So it goes in the
backwards
backward state. So if delta G is greater than 0, it means it goes in backward direction. It is endergonic reaction. Using the thumb rule given in class, if the ATP increased by 104, what would be the new delta G value for the reaction? 2 multiplied by 6. This is 6. Then we multiply by 2 by 6. It is around 12. So minus 12 and plus 12. We have a difference of minus 6 kilojoule per mole in both of the reaction. Here the value of redox potential is given, and we also have the equation of conversion of pyruvate into lactate. During the conversion of pyruvate into lactate, there are two electrons which are provided by NADH to pyruvate to produce lactate. So the difference of electron is 2, and we also have a redox potential value which is around 0.13 volt. So we can put into that equation del G is equal to minus NF del epsilon. So the value of electron is 2. Then we have F value which is 96.49. Then we have a Dox potential value which is 0.13 volt. So we have our overall energy of 25 kilojoule per mole during this redox reaction. So during the conversion of pyruvate into lactate, we have Gibbs free energy around 25 kilojoule per mole. So in this diagram, we have seen that the last gamma phosphate molecule has highest energy because it has a phosphodiester bond with the phosphate molecule, and it has an extra negative charge on it. So the last gamma phosphate group has high energy, and the second beta phosphate has less energy as compared to gamma because it only contain -1 charge. It contain -2 charge. And third, which is attached to the ribose 5 carbon, it has little energy because it has bonding with the fifth carbon of ribose, and it has less energy as compared to other phosphodiester bonds of phosphate molecule. So you can say the phosphate molecule which is present in the third position, which is known as gamma position, has highest energy, and beta phosphate group has lower energy, and alpha phosphate has lowest energy because it has weak linkage with the fifth carbon of very stable linkage with the fifth carbon of ribose sugar. So the instability between the third phosphate group and second phosphate group yield more energy as compared to this phosphodiester linkage. So you can say third phosphate group has highest energy, then second, and then third. State 2 of the factor that make cleaving the high energy linkage especially favorable. It is due to hydrolytic cleavage in the presence of water. It may be increased resonance and separated negative charge. That's why it has cleavage ability by due to these two factors. Hydration, increased hydration can break this phosphodiester linkage, and increase resonance and separated negative charge. So a third phosphate group have two negative charge. That's why it has a strong separation ability as compared to other phosphate groups. Here
So
we
it's potential. Oh, so because of the potential for hydrolysis,
yes
that's like when you mean by like hydration, it just means that it's more likely for hydrolysis to occur. And so
yes
that's why.
if we have more negative charge, there is more chances of hydrolysis because of the
Okay.
interaction with the water molecule. Okay. There are two types of nitrogenous bases which are present in the DNA and RNA. These are pyrimidine and other is purine. Pyrimidine is a uracil, thymine, and cytosine. These are single ring nucleotide bases which are present in both DNA and RNA. In DNA, we have cytosine and thymine, and in RNA we have cytosine and uracil in place of thymine. So uracil can be converted into thymine by methylation on fifth carbon. So uracil is known as 2,4-dioxypyrimidine. Why? It has carbonyl group on second and fourth carbon. So you can say this thymine is known as 5-methyl uracil because rest of the structure is similar to uracil. And we have cytosine. What is the difference between uracil and cytosine? We have amino group in place of a carbonyl group on carbon 4. So these pyrimidine bases present in both DNA and RNA. And we have purine bases. These are double ring bases. In first ring, we start counting in clockwise direction, and in second ring, we start counting by anti-clockwise direction. But in pyrimidine bases, we always start counting from anti-clockwise direction: 1, 2, 3, 4, 5, and 6. But in purine, we start counting from clockwise direction in first ring and anti-clockwise counting in second ring. So adenine is known as 6-aminopurine because it has amino group on 6 carbon. And guanine is known as 2-amino-6-oxopurine because it has amino group on second carbon. And carbonyl group on 6 carbon. So in DNA, we have always pair of A with T and G with C. This is the basic concept. A and T has 2 bonds, 2 hydrogen bond. G and C has 3 hydrogen bond. So G and C has more stability, and A and T has less stability. Why? Because G and C has 3 hydrogen bond between the bases, and A and T has 2 double bonds, which has less stability as compared to G and C. Here we have a figure. We have adenine structure. Adenine always bind with the thymine, which have 2 hydrogen bonding. This is the actual structure, and there is no ambiguity about it. Adenine always attached with the thymine. Okay. Explain. And if we have a cytosine here, what happen? Or guanine here, what happen? If we have guanine here, what happen? It has three hydrogen bond with the cytosine. Okay. So adenine always have bonding with thymine, and guanine always have bonding with the cytosine. Adenine and thymine has 2 hydrogen bond, but guanine and cytosine has 3 hydrogen bond. So this is the basic difference between 4 nitrogenous bases in terms of bonding. Explain what makes the covalent structure of DNA much more stable than that of RNA, because DNA is a double standard structure, and also one major reason is that on second carbon we have less oxygen in deoxyribose, which make more stability, which give more stability to DNA. Why? No tag on terminal phosphodiester bond due to lack of hydroxyl group on second carbon of deoxyribose, which make it more stable. So there is no phosphodiester internal linkage possible if we do not have a hydroxyl group on the second carbon of deoxyribose. Why should hydrogen bonding not be considered a strong net driving force that stabilize the duplex DNA? Simple, because single stranded DNA make hydrogen bond with water because of the negative charge of a phosphate group with all available groups. So very little net change in charge upon folding. So single stranded DNA has attraction with water. So all available group has very little or net change in charge upon folding. Under what condition does double stranded DNA adopt the A form helix, and why B form DNA disfavor under that condition? When BDNA is dehydrated under high salt condition, when we provide high salt concentration like ammonium sulfate, the BDNAs get dehydrated, so BDNA is converted into ADNA. Here you can see the difference between the water molecule. ADNA has 75% of water and BDNA contain 92% of water. So during dehydrated condition, this BDNA can be converted into ADNA. And the distance between digesting bases get decreased due to that dehydration. So loss of spin of water in the minor group destabilize the structure of negatively charged backbone of DNA. So that's why we can say the DNA is more favorable. The increase in absorption at 260 that occur when B form of DNA duplex melt is called the hyperchromic shift. What is hyperchromicity? Is the increase of absorption. This increase of absorption is observed. Why? Because the decrease in distance between adjacent bases due to dehydration. So there is an increase in absorption of ADNA when we have a dehydration effect. What cause, and this overall effect is known as hyperchromic shift, mean the increase in the absorption when the BDNA is converted into ADNA. What causes the increase in absorption? Low